Hey everyone, good afternoon. This is Sagar. Uh, yeah, it's almost 2 o'clock, so I think we can get started. So let's first talk about the topic that I'm going to cover today, and followed by my introduction, and then we start going through different concepts. So today, first of all, very warm welcome to everyone, and thank you so lot for joining the session. Today we are going to talk about near real-time analytics using Azure Synapse. Coming back to introduction, so my name is Sagar. I have total 9+ years of IT experience, currently working as a cloud solution architect for data analytics team for financial client, currently working in Netherlands. Uh, I do like blogging, writing, and speaking at various events, share my knowledge with the community. That's briefly about me. So let's start with the actual session. So the agenda for today's session is we are going to look at the introduction of Cosmos DB and the Synapse link, how we can create a Synapse link, and with Cosmos DB we can enable the near real-time ingestion. And then we are going to cover end-to-end real-time analytics example with hands-on example using Azure Synapse with Cosmos DB. And at the end, we can take up any questions if you have. So feel free to ask any questions if you have in even in between, or you can put the questions in the chat. So let's get started. Let's start with the introduction to Cosmos DB and Synapse link. So first of all, before we talk about Cosmos DB and why do we need Synapse link, we need to understand what are the challenges currently we have while working with the traditional workload. There are various traditional database available in the market. It can be relational or it can be non-relational database like Neo4j or any other database. Then why do we need Cosmos DB and Synapse? So the major challenge that we face with the traditional analytics workload is manipulating the amount of provision throughput. So we cannot determine the number of amount of compute power required while working with the traditional databases at beforehand. Using the chain data feature to move the data to Cosmos DB. There are multiple requirements where we need to capture the history, we need to capture the SED type too, which is not possible with the traditional database. And then we need to do the development and create a custom ETL code or a mechanism to move data to Cosmos DB. So it requires some development efforts and maintenance efforts as well when we work with the traditional workload for Cosmos DB. Now, in order to overcome these limitations or the topics that we talked about, we can use Azure Synapse link for Cosmos DB, which will make our life more simpler and easier. So if we use Azure Synapse link for Cosmos DB, then first of all, it will enable analytics. It will enable analytics over the transactional data without impacting the existing transitional workload. The Cosmos DB Analytics Store allows us to sync traditional data into the column store. So basically, Cosmos DB is a NoSQL database. So when we store the data, we can store the data in multiple formats. There are four kind of APIs available. We can store the data in the form of columnar store. We can also store the data in the form of graph database or a document database or a SQL API. So there are various like four types of APIs available while using Cosmos DB. No need to develop and manage any complex ETL jobs because we can ingest the data directly without using any code or any ETL pipeline. So it will avoid the development efforts as well as the maintenance efforts. And the last feature is near real-time analytics with the data. So once the data is available in Cosmos DB, first of all, we can ingest data in a near real time. And on the other hand, we can also perform analytics on the top of data available with Cosmos DB. So this way, the Synapse links with Cosmos DB makes our life much easier. Now, after understanding the need and the advantages of using Synapse link with Cosmos DB over the traditional workload, Let's also get a quick glimpse of what this Cosmos database offering from Microsoft is. So basically, Azure Cosmos DB is Microsoft globally distributed multi-model NoSQL database, which allows end users to elastically and independently scale in terms of throughput and storage. So basically, it's a NoSQL database which comes up with multiple APIs as we discussed earlier. It can scale automatically. It is basically, we can scale this database in the form of throughput as well as storage. So no need to worry about storage and no need to worry about the compute power also beforehand. So that way it will improve the performance and high availability for the database and the data available in Cosmos DB. There are basically four types of APIs available while when we start working with Cosmos DB. So there are you can store document data which is in the form of SQL DB or MongoDB API. If you want to store data in the form of key value pair, then you can use table API. If you want to store data in the form of columnar data, then you can use Cassandra API. And if you have a use case or a scenario where you want to store or maintain the data in a graph format, then you can use Gremlin API. So these are different type of offerings available, APIs offerings available with Cosmos DB. Uh, One of the major advantage of using Cosmos DB over other databases, it is highly responsive and available worldwide. So it will ensure that user data is as close as possible, and it will also guarantee low latency or low delay for both read and writes. So we can easily read the data from Cosmos DB and we can also write the data into Cosmos DB at the nearest available Cosmos DB location or instance. Apart from the availability feature, Cosmos DB also comes up with various consistency models. So it offers strong, bounded stillness, session, consistent prefix, and eventual. So these are the consistency model that you can choose in or you can select in while using Cosmos DB. So this will give more flexibility with respect to the use case or project or application that you are building upon. So this is briefly about Cosmos DB. Let's move on to the next slide. After understanding the quick overview of Cosmos DB, let's also understand what is Azure Synapse. So Azure Synapse is also one of the offering from Microsoft. It is an integrated analytics service which basically allows to use SQL and Spark for the data for the analytical and data warehousing needs. So it is basically an analytics service by which we can use SQL and all the features of Spark to perform our data warehousing and analytics activities. Basically, with Synapse, we can easily build a pipeline for data integration, ETL, ELT, or machine learning purpose. Another advantage of using Synapse is we can easily integrate Synapse with other Azure services like Azure ML, Power BI, or Cosmos DB. So let's say if you want to create an end-to-end use case where you want to get the data from the source system, create some ETL pipeline to do some extraction, transformation, and loading. And once the gold data is available, you want to connect to Power BI to generate the Power BI reports with some visuals for your business users, then Synapse is a perfect fit. Apart from this, Synapse also provides us with unified management, monitoring, and security over the enterprise data lake. So nowadays, most of the companies and enterprise organizations are moving towards cloud. They are building data lake or delta lake or data lake warehouse. With Synapse, it provides us a unified experience where we can, let's say, build our data application. We can also monitor our application and we can also make our application more secure by enabling proactive monitoring, etc. Apart from this, once you deploy Azure Synapse, it also has Synapse Studio, which will basically allows data engineers, BI engineers, and data scientists to provide a unique experience to build the analytics solution. So this is briefly about Azure Synapse. Now let's talk a bit about Azure Synapse Link for Cosmos DB. So Azure Synapse Links for Cosmos DB is a cloud native capability, basically hybrid transaction and analytical processing. So it with this feature of Synapse Links for Cosmos DB, basically we can run the near real-time analytics over the data available in Cosmos DB via the analytical store. So we can basically perform the near real-time analytics on the top of data without having to creating an additional pipeline or maintaining the ETL pipelines. So this is, let's say, our Cosmos DB database with this or OLTP with some row-based index 6. On the top of this, we just have to enable this Synapse link feature. And once we enable this feature via Cosmos DB analytical storage, we can near real using Synapse, we can ingest the data in a near real time without developing any ETL pipelines. So this way, it makes the development and maintenance much easier and less complex to manage. We also talked about Cosmos DB analytics store. So let's understand in detail what it is all about. So Cosmos DB analytical store is an isolated column store which allows to perform analytics against the transactional data without impacting the transactional load. So let's say you have a Cosmos DB database in which you have stored the transactional data with SQL API. Now, if you want to perform analytics on the top of it without impacting the data stored in Cosmos DB, this Cosmos DB analytics store will transform the data into a columnar store format. And once it is available in the columnar store format, you can directly perform the analytics. So no need to do any intermediate transformation or processing in between. Store is a row store, which is optimized for transactional read and writes. Another major advantage of using this Cosmos DB analytics store is it is schema agnostic. That means if today you have 5 columns and tomorrow if the schema changes, maybe one column has been dropped or one column is added, then no need to worry about changing the schema. Without changing the schema, you will be able to ingest the data. And on the other hand, also if there is any change in the data type, it will take care of it. It also allows to iterate the application without managing the schema and indexes. Now, with this Cosmos DB Analytics store, we can also perform super fast transactional read and write with his Cosmos DB. Another major feature of this analytics store is we can extract the data out of Cosmos DB into a separate data layer on the top of, and then we can perform the analytics workload using the change feed. So let's say we can spin up an Azure function to listen to a container for any insert. So whenever the new files are inserted or added to the container, then it will insert then it will basically directly trigger the change feed mechanism of Cosmos DB to get the data from the blob storage or ADLS into to Cosmos DB. So this is one of the another major feature of Cosmos DB Analytics Store. The Analytics Store is a columnar store, which is an optimized format to perform the analytics. So basically, it will reduce it will improve the query performance. We can also sync the operational data into our row store into a separate column, which enables to perform the analytical query without building the ETL pipelines. We can also enable analytical store on container inside Cosmos DB, and the operational data inside the transaction store, which is persisted separately. Data will be synced automatically, so no need to basically do any development or maintenance for the change feed or create any complex ETL pipelines to perform analytics on the top of data. And with this auto sync feature, regardless of the intensity of transactional traffic, it will improve the performance of the transactional workloads. So these are some of the features of using Cosmos DB Analytics Store. In the analytical store, there are basically two types of mode for schema representation: well-defined schema and full fidelity schema. When we talk about well-defined schema, it will basically present the data in the form of tabular format in the transactional store. But when we look at the full fidelity schema presentation, you will be able to handle full breadth of the schema which exists in your transactional data. In well-defined schema, properties in the document always have the same data type and the array type, and the array type must be a single repeated type. But in the full fidelity schema, you don't have any constraint. Basically, there is no schema or no any restriction or requirement. So when the analytics store is enabled with SQL API, the default mode is well-defined schema. And in the MongoDB API, the default is full fidelity schema. Now, after understanding the basics of different components of like Cosmos DB, Azure Synapse, Synapse Link, and Cosmos DB Analytics Store, let's understand in detail how we can perform it practically. So first of all, you have to enable the Azure Synapse link. So once you open your Azure Cosmos DB account from the portal, on the screen, you will be able to see multiple options. So there is an option to create a new container in Cosmos DB, enable Synapse link, new notebook, connect to the GitHub, etc. So go to the Data Explorer and click on Enable Azure Synapse link option to enable the Synapse link. Now, once you enable this feature, it will take few minutes to take an effect. But once it is done, we can go through the process. We can go through the process of setting up the container for the analytical store. Now, once the Synapse link is enabled, the second step is to set the container to use the analytical store. So, in order to do that, first of all, we have to we have to create a Cosmos DB container with analytics store enabled. We can do it with Portal. So, in order to do that, first of all, again, go to the Data Explorer, click on a new container, so you will get an option. Once you click on a new container, the pop-up will appear where you have to provide the container name, partition key, throughput, whether it is auto scale or manual. So based on your requirement, you can choose the throughput part, and then estimated once you select the maximum RU, or if you use the manual option, then you can specify the maximum request unit based on the configuration. It will provide you the approximate cost. And then at last, there is an option to if you want to enable or disable analytical store or not. So this is where if you select on, then you will enable analytical store for your Cosmos DB container. So this is the second step. Now the third step is to set up container to use the analytical store. So once the container is created and based on the configuration that we did it in the last step, uh, we will be able to configure various analytical storage time to live. So there are multiple options. If there are settings where time to live option, if you want to enable it on and off. So based on your requirement, we can select it. If you want to enable geospatial configuration, then if you want to do it at a geography level or geometry level, that can be done. And analytical storage time to live, you can set it to on and off. So these are container enable settings that you can select once we enable the analytical store. Then let's also understand briefly about what these features are. So analytics time to live. So what is time to live feature when we enable the this? So time to live for analytical store states how long we want to keep the data in the analytical store. This setting is isolated from the time to live setting for transactional store. Since these two settings are different, data archiving becomes simpler for us. And analytical store is optimized in terms of storage compared to the transactional store. Apart from this, another advantage is we can retain data for a longer time in analytical store by setting this feature. So that is one of the advantage to configure and make this feature on. Now the next step is we want to connect Azure Cosmos DB to the external data to Synapse. So we have to what we have to do is we have a container with analytical store enabled. We can now connect our Cosmos DB account to the Synapse workspace. So if you don't have a Synapse workspace, then first of all you have to create a workspace, and then once the Synapse workspace is created, what you can do is you can go to the Cosmos DB, you can go to the Synapse works, you can go to the Cosmos DB instance from the Data Explorer in Synapse. Basically, you can select connect to the external data, and there you can choose the Cosmos DB instance that we create and link it as an external source. So that way we can connect Cosmos DB in the Synapse workspace. Now, connecting to the Azure Cosmos DB to Synapse, once you click on that button, you will get multiple options. So from this option, you have to select the relevant Cosmos DB instance based on your preference. So at the time of writing, we can connect SQL Cosmos DB account at a with SQL API or MongoDB API. And now another point to note is if we have a globally distributed Cosmos DB account, then analytical store will be available only for the container in all the regions of that account. And changes in the transactional store is replicated to all the regions associated with the Cosmos DB account. So when we run the query against the analytical store, we will be running the query against the nearest regional copy that we have for Cosmos DB, due to which the performance and the availability of the data in Cosmos DB is high and there are no latencies or less latencies. So this is one of the major advantage. Now, once you select the Cosmos DB as an external connector, you have to provide the link connection name. So this is the name. You can give any name. It should be readable and human readable format. Now you have to select the Azure subscription. You have to provide the Cosmos DB instance. And once we created a connection, then it will appear in the link tab. So in the Synapse workspace, you'll be able to see that there is a Cosmos DB connector available with this name. Now we can differentiate between the container that have analytics store. How we can differentiate between the container of Cosmos DB, which has analytical store enabled and analytical store is not enabled. So basically, if you look at the right hand side, if you are able to see your container with this icon, that means that analytical store is not enabled. And if you are able to see this kind of icon, then the analytical store is enabled. Now, we need to create an Apache Spark pool. So in order to do this in Synapse Workspace, you can go to the Manage Pool and click on the Create Apache Spark pool to create a new Spark pool. Now, this is the screen that you have to go to when from the Synapse workspace. And if you click on a new button, then you will get an option to create a Spark pool. Now, in order to create a Spark pool, you have to provide some basic configurations. So in the basic tab, you have to provide the Spark pool name, what should be the node size, whether you want to enable auto scale or not, number of nodes, and this is the approximate cost. Now, once you provide all the information, the Spark pool will be created. And if you want to make these changes applicable, then you have to publish your Spark pool, so it will be available for all the users who are using this Synapse workspace. Now, the next step is how we can basically work with the analytical store in the Azure Synapse. So first of all, let's take an end-to-end example where we have here in this example, I have created a simple device reading container which has 100 documentation. So this is one of the documentation. So like this, it is a JSON file in a key value pair format where this is one of the examples. So likewise, we have around 10,000 documents. Now, what we wanna do is we want to try querying the data using Spark. So when we want to query the data, we can either load the data to Spark data frame or we can create a Spark table. So in Synapse Apache Spark, we can query the data in Cosmos DB without impacting the transactional workload. So we can insert the data into Cosmos DB via Spark in Synapse and use structured streaming as about source and sink to ingest the data in near real time. So this is the PySpark command that you want to when you want to load the data into a Spark data frame. So this is spark.read.format and the format name is cosmos.olap. This is an option where we are providing the Synapse link service that we created in the Synapse workspace. And the option is for the Cosmos DB container from where you want to read the data. Now, once it is done, you will be able to see the data frame has been created. And when you display your data frame, you'll be able to see the data as well. So this is the data frame df.show command output. Now, what we want to do is we want to drop some columns. So on the top of data frame that we created, we want to drop these 3 columns. Once you drop the columns, then you'll be able to see the column now no longer contains these 3 additional columns. Now we have prepared a final data frame, which we can use it in Synapse to perform the analytics. Uh, that means that the queries that we run in the target analytical store, meaning that these queries have no effect on the transactional workload. So in our data frame, we have a column for how the old device is in days. So let's see what are the oldest and what kind of damage that have been applied on different fields. So here we are doing some order by based on age in days in a descending order, and then we are displaying the first 10 records. So working with analytical store in Synapse, here I'm just demonstrating the capability of being able to query the analytical store with Cosmos DB using Spark without affecting the transactional workload. But that is not, we are not, that is not the limitation to query the data in Spark. So instead of Spark, let's say if your end user or if your teams are very much comfortable using T-SQL, then using T-SQL as well, you can use serverless SQL pool. So when we provision in Azure Synapse, you can immediately have a serverless SQL pool, like how we created for the Spark pool. So there is also one of the feature. If you're more comfortable with T-SQL, then you can use the SQL pool. Now, after understanding the feature, let's also talk about the cost of Synapse links for Cosmos DB. So when we use Synapse link for Cosmos DB, you will have to pay for both analytical store in Cosmos DB as well as the Synapse Analytics computer processing power that we are going to consume. The analytical store follows the consumption-based pricing model. So basically, you have to pay as per your usage. So you will be charged for the storage retained in the analytical store for both read and writes, while the pricing is separate from the transactional store. So you don't have to provision any additional request unit as we have to do it in the transactional store. Uh, there are also some limitations of using Synapse Link with Cosmos DB. So first of all, it is only available for SQL and MongoDB API. It is not available for Gremlin API. For any containers with analytical store enable, automatic backup and restore of the data is not currently supported. So if you want to restore your transactional data store, then container will be restored without the analytical store enabled. Yeah, so that's it for today's session from my side. So anyone has any queries or any questions, feel free to unmute yourself and ask, or you can put it in a chat. Yeah, and over to you, Drago, then.